Okay guys, today we're doing lesson 1.2, finding cube roots. So a cube root is a number that when multiplied by itself and then multiplied it by again, it equals the given number. So for example, if we do the square root of 25, we know that that's 5 because 5 times itself, 5 equals 25. So cube root is where you have a number times itself 3 times. Okay, so on these first few examples, A, B, C, and D, if we look at these right here, we're finding the cube root. I know you'll know how to plug it in your calculator, but these are basic ones where you could do it without your calculator. So on A, the cube root of A. Well, if you see here, it says because 2 to the third power equals 8, the cube root of 8 is 2. So 2 times 2 is 4. 4 times 2 more is 8. So the cube root is the exact opposite of raising a number to the third power or cubing it. Just like if we have a number 2 squared, 2 to the second power, that's the exact opposite, well, it doesn't equal, it's the exact opposite of the square root. Square root and squaring a number are exact opposites. So therefore, the cube root and cubing a number are also exact opposites. So on this second example on B, if you'll notice, we have the cube root of negative 27. Okay, cube root of negative 27. So that actually brings something else in that I want to talk about, this negative sign. When we're taking the square root of a negative number, you cannot do that because if we had the square root of negative 25, that means what number times itself equals that? Well, 5 times 5 equals positive 25, but negative 5 times negative 5 still equals positive 25. So there's no way you could get a negative answer. But when you're doing the cube root, so the cube root of negative 27, we can because we're multiplying a number 3 times. So on this one, we'll just work it out. Let me see if I can make this any smaller. Okay, so what we do, if we have negative 3 times negative 3, sorry, this is not the best writing, times negative 3. Okay, well, negative 3 times negative 3 is positive 9. But then you still have times one more negative. 9 times negative 3 is negative 27. So when it's cube root, you can have negatives. So when we have a negative inside the cube, that means your answer is going to have a negative. Okay, so whenever we see the cube root of negative 27, we know 3 times 3 times 3 is 27, and we know it's going to be negative. So our answer on that one is negative 3. Okay, on C we have a fraction. So what we do when we have a fraction, right here on C, it says the cube root of 1 over 64. You kind of think of it, you can go ahead and look at the whole fraction, or you can almost think of it as putting that cube root on top and doing the cube root again on bottom. You keep them separate from each other. So over here it says, well, we know 1/4 to the third power equals 1 over 64. So they go ahead and tell us that the cube root is 1 over 4. But what you can do to break it down, well, what is the cube root of 1? What times itself 3 times will equal 1? And that one's easy because it's just 1. But when we look at the bottom, 64, the cube root of 64 comes out to 4 because 4 times 4 is 16. 16 times 4 more is 64. So the cube root of 1 over 64 is just 1 over 4. Okay, and then this last one, we have the cube root of 27 over 125. So again, just like on that previous one, break it down and just do the cube root of the top number, then do the cube root of the bottom number. So the cube root of 27, we already kind of looked at it on B, is going to be 3. The cube root of 125 comes out to 5. 5 times 5 is 25, times 5 more is 125. Okay, so what you're going to do now, I know you can't see the examples that I want you to try on this page, and it won't let me scroll. So what you'll do, I'll write them on the board. You'll write them down, then I want you to pause your screen or pause your video so that you can work them out first, then press play and I'll work them out so you can see if you did them correctly.
Okay, so the three examples, I know they maybe got cut off, so I wrote them right here. This says the cube root of 1, the cube root of negative 343, and the cube root of negative 27 over 1,000. So pause the video if you haven't already and try these problems, and then you can press play and watch me work them out. So this first one, the cube root of 1. Well, it just means what number times itself 3 times equals 1. So that one's very easy. It is 1. If you missed that, we need to talk. This next one, the cube root of negative 343. And don't forget, like I already said, when you have a negative in there, being that it's cube root, we can have that. But that means our answer is going to be negative, because a negative times a negative is positive, but then you have that answer, a positive times one more negative. Positive and a negative is negative. So we already know the answer is negative. We just have to figure out what number times itself 3 times equals 343. And if you do that on a calculator, or if you know it, it is 7. So negative 7. Okay, this last one. If you didn't know how to do this, this would look pretty scary. It's not. Okay, so we have cube root. You can split them up. We already know there's a negative, so our answer will be negative, so we can go ahead and deal with that. Then do them separately. What is the cube root of 27? What number times itself 3 times equals 27? And that is 3. Then you do the cube root of 1,000. It's a number times itself 3 times, that is 10. 10 times 10 is 100. 100 times 10 more is 1,000. I said 10, and then I was about to write 1,000 because I said it. So we have negative 3/10.
Okay, so now let's looking at example 2. It says evaluate each expression. So now we have several things happening in the problem, but we also have cube root in there. So if we look at problem A, and you can choose to write these down or not, guys. You have to write the ones I have you work out down. But these, if you'd like to work them out step by step so you have more examples, that's perfectly fine too. So on A, we have cube root of negative 216 minus 3. So this 2 out front means 2 times that. Well, using our order of operations, our PEMDAS, we can't multiply that till we get rid of this. Cube root or square root or any root is kind of like parentheses. You have to get those done first. So we first start with the cube root of negative 216. And since it's cube, we can have a negative. It just means our answer for that will be negative. And the cube root of 216 actually comes out to 6. And if you didn't know that, you could just play with numbers or do the cube root function on your calculator. So all they did from here to here is they did the cube root. We still have 2 times, now we have negative 6, and then minus 3. So order of operations, we have to multiply next. 2 times negative 6 is negative 12, and then we still have minus 3. So negative 12 minus 3 more is negative 15. So then on problem B, we have the cube root of 125 all raised to the 3rd power plus 21. Okay, so again, we can do cube root first because parentheses, then exponents. The cube root of 125 is 5. So here we have 5 to the 3rd power plus 21. So we have to do that exponent. 5 to the 3rd power is 125. Plus 21 more is 146. Now, I want to actually look back at this one up here. I kind of mentioned it earlier, but we have the cube root here, all raised to the 3rd power. And if you remember me mentioning just a while ago, cube root and a number cubed, or to the 3rd power, are exact opposites. So when you have a cube root raised to a 3rd power, they just cancel out. And you're left with, let's see if I can do this hand better, 125 plus 21. So it goes ahead and it skips a step. And then when you add those, you would get 146. Okay, I know that's not the prettiest. Sorry about that. So what I want you to do now see if I can turn it off. There we go. Is I want you to attempt 4, 5, and 6. Okay, you're going to do problems 4, 5, and 6. Then you can press play and I will work them out for you. But I want you to try them on your own first. So pause the video, work out those 3 problems, and then press play and I'll work them out for you.
Okay, so problems 4, 5, and 6. If you haven't already written them down, pause and do so and attempt them first. So on problem number 4, we use our order of operations, PEMDAS. We don't have any parentheses, but if you remember, the square root, we treat it, or excuse me, cube root, we treat it like parentheses. So we have the cube root of 8. A number times itself 3 times, that equals 8. That would be 2. So I'm going to rewrite everything else. I solved for this. 4 times 2. And let me know in class if you can't read this green very well, and I'll stop using it. So now we have to multiply. 4 times 2 is 8. And 18 minus 8 is 10. I hope you got that. Okay, the next one, we have parentheses. We have to do what's in parentheses first, and I have to do the cube root of negative 64. Remember, cube root of a negative means your answer will be negative. The cube root of negative 64, if you plug that in your calculator, is negative 4. I now do my exponents. Negative 4 to the 3rd power means negative 4 times negative 4 times negative 4, which is negative 64 plus 43. When I compute that, or plug it in your calculator, you get negative 21. Now, I do want to talk about, if you come back up, and just like I mentioned in the example I worked out for you, when you have the cube root all raised to the 3rd power, those are exact opposites of each other. So from the beginning, I actually could have just canceled that and had negative 64 plus 43. It just skips 2 steps where you're already right there to solve. Okay? All right, number 6, last one. We have a 5 out front being multiplied. So I have to do the cube root of 512, which is 8. Double check me in your calculator. We have 5 times 8 minus 19. I have to multiply before I can add or subtract. 5 times 8 is 40. 40 minus 19 is positive 21. There are, so 10, negative 21, and positive 21. If you missed them, just try and look back and see if you can figure out where you messed up. Because most of the time, it's an easy mistake that you spot. You're like, oh, okay, I get it now. All right, so now let's look at the next example.
Okay, now we're going to look at example 3. On this one, we're evaluating algebraic expressions. So a lot of you, when you see problems like A, so we see that it's x over 4 plus the cube root of x over 3 when x equals 192. For some reason, when y'all see fractions like this, you like freak out and you think it's going to be really difficult. But a lot of times, it just looks scarier than what it actually is. Okay, A is a perfect example of that because if we look at it being worked out, the first thing we always have to do on these is rewrite it. So I plug 192 in for x. So I have 192 over 4 plus the cube root of 192 over 3. Well, when a number is over something, that actually means divide. So 192 divided by 4 comes out to 48, a nice number. Plus, if we go ahead and divide this, 192 divided by 3 actually equals 64. So our problem now is just 48 plus the cube root of 64. So already much better. The cube root of 64, just like parentheses, we have to do that first, comes out to 4. So our problem then is just 48 plus 4, which is 52. So once we kind of simplified these, it no longer looked very scary, and then it was pretty simple to evaluate the rest. Okay? Then if we look at problem B, we have 9x plus the cube root of x when x equals 1 over 27. So the first thing we always do is we rewrite it. This 9x means 9 times x. So I have 9 times 1 over 27 plus the cube root of 1 over 27. So this 9 times 1 over 27, that means 9 over 1. Let's see, 9 over 1 times, that's supposed to be a parentheses. This is not easy to write on for me. 1 over 27. So then if we multiply straight across, I have 9 over 27. Okay, well then we can simplify. You can actually divide 9 out of both of those. 9 divided by 9 is 1, 27 divided by 9 is 3. That is how they got this 1 over 3. Okay, so then we have plus the cube root of 1 over 27. So again, if you remember how I told you earlier, you kind of split it up. The cube root of 1 is 1. The cube root of 27 is 3. So now we have 1 over 3 plus 1 over 3, which you just add straight across and keep your denominator, 2 over 3. So this problem is a good example of why if they give you fractions to begin with, it's probably going to be easier to keep it a fraction because 1/3 and 2/3 as a fraction, as a decimal are repeating decimals. So it's better and more accurate to have those as fractions. So keep them a fraction if they start out that way. So what I want you to do now is you can write down problems 7 and 8 and attempt those, but I'm actually going to go ahead and look at example 4 before I go back and work out 7 and 8 for you, okay? So you can pause the video and attempt to work those out, but then it won't be until I'm done with example 4 that I'll work those out for you. Okay, so on example 4, this is going to be the last example we do together today. It says evaluate 5 times the cube root of 3x minus 9. That 3x minus 9 is all inside the cube root. Then there's still a minus 7x. And then they tell us when x equals negative 6. So the first thing we always do on these is we rewrite it or substitute in that negative 6. So my problem goes from this to when we plug it in with 6, it looks like this. Now, we know this cube root works like parentheses, but inside the cube root, I have other stuff happening, so that's technically where I begin. So we have 3 times negative 6, which is negative 18 minus 9 more. When we do that, we get negative 27, so I have 5 times the cube root of negative 27, and they went ahead and multiplied this out here, 7 times negative 6, but it's actually a minus 7, so negative 7 times negative 6. Negative times negative is positive, so they got plus 42. I probably would have done that later on, but it's okay because it's on the outside of that. So when we have this cube root of negative 27, that is negative 3. So then we have 5 times negative 3 plus 42. 5 times negative 3 is negative 15, plus 42 is 27. So these take several steps to solve, but you're just having to compute and use your order of operations. So what I want you to do now, here's problem number 9, write it down and work it out, so pause the video, and then I will work out 7 and 8 from the last example and 9 for you.
3 examples, 7 and 8 from example 3 and 9 from example 4. So on this first one, number 7, we have the cube root of 8y plus y when y equals 64. The first thing we always do on these is we write it down with the number in there. We rewrite it. So over here we have the cube root of 8 times 64 plus 64 outside that cube root. Well, 8 times 64, if you plug that in your calculator, is 512. Then the cube root of 512 is 8. Okay, and then the last thing we do is add. 64 plus 8 is 72. Okay, example 8. First thing we have to do is rewrite it. Remember when the letter's right next to the number, it means multiply. We also have it inside this cube root. So I have 2 times negative 3 minus the cube root of 9 times negative 3. I'm going to go ahead and do this even though technically this is not the first step, but you can do this since it's being separated. That's negative 6 minus the cube root of negative 27. The cube root of negative 27 is negative 3. So don't forget, we have negative 6 minus negative 3. Whether it's in parentheses or not, a minus and negative can't have a double negative, 2 negatives. That becomes positive. And we have negative 6 plus 3, which is negative 3. Okay, last one, problem number 9. Now on this one, we have a lot happening inside that cube root that we have to do first. Remember, we treat it like parentheses. Okay, And it says 4x minus the cube root of 6x plus 2 when x equals negative 11. So I have 4 times negative 11 minus the cube root of 6 times negative 11 plus 2, all inside that cube root. So I'm going to start with that. 6 times negative 11 is negative 66, plus 2 is negative 64. So I have 4 times negative 11 minus the cube root of negative 64. I'll start with the cube root. I'll do it in order. I'm sorry. That was my fault. Cube root of negative 64 is negative 4. 4 times negative 11 is negative 44, and we still have that minus between them. So just like on the last problem, the last example, a negative and a negative makes a positive. Negative 44 plus 4 is negative 40. All right, so now you will look in Google Classroom for what your assignment is, okay? Peace up, A-Town down. If anybody can tell me who sings that, the name of the artist and song, I'll give you some bonus points and some candy.